So, thank you for inviting me here. Good to see you, Lance. My name's Josh Seiden. I've actually, been, following Ellen and Mark and the Atlas program for quite a while. I'll tell you a little bit about myself before we jump in. I am actually a graduate of CU. Many years ago, many years ago. So, over 3 decades ago, we'll leave it at that. But when I was here, I actually was in a program, an undergraduate program, not that dissimilar from what Atlas is. So I was in a program that was a distributed studies program between arts and sciences and engineering, and I majored in computer science and astrophysics. And at the time, I thought I was going to go build rockets and spaceships and all that kind of stuff, and didn't really work out that way. It actually worked out a lot better for me. So turned out what I did while I was in school, there weren't a lot of people that had experience with astrophysical, planetary, and atmospheric science, which was one half of my major, and computer science. And it was also a time when the world was switching from mainframe computing to client server computing, and the programming languages were literally being flipped upside down. And if you think that, an old school scientist is stubborn, you have no idea how stubborn they are. And they refused to learn a lot of these new programming languages. So they hired students at a CU, and I worked for 2.5 years while I was in school at NCAR, the National Center for Atmospheric Research, and I wrote all the software that the scientists didn't want to write. And it was a great job. And what that job actually allowed me to do is, at that time in the early 90s, without knowing it, I was at the forefront of digital imaging. I graduated from this university with more knowledge about digital imaging than just about anyone else in the industry, in any industry. Just happened that way. The timing was right. And what that led me to was, believe it or not, don't laugh, cable television at the time. And
It's your fault.
it is my fault. But there's a reason why. And the reason why was, at that time, all television was analog video. And a man by the name of John Malone, who many of you may have heard of, he's one of, if not the wealthiest man in Colorado, but one of the most innovative thinkers in telecommunications. He had this idea that all video, all television was going to be digital and non-analog. And I got really lucky. I graduated from this university, and that whole industry plucked me out of there and said, we have to have people like us. And so I started a career at that time building the world's first digital television systems. And those are now adopted everywhere, which all led to streaming and everything. And I went through a career path of going through a company called TCI, which at that time was the world's largest cable company. Then that became AT&T Broadband, which was also became the world's largest cable company. And then Comcast. And at Comcast, about 17 years ago, I was picked by the CTO to be part of an organization called Comcast Labs. And the goal of Comcast Labs was to be not encumbered by budget. It was to be only opportunistic in technology and find ways to take new technologies and apply it to anywhere in the business. And I did that for about, that particular role for about 15 years. I ran that organization. And now what I do is, I work with startups as sort of a fractional CTO. So I'm working with 4, maybe 5 at the end of this week, where I help them take their technologies, figure out the best ways to use their technologies, figure out how to build a business around it, and hope that they're successful. So that's sort of what I do now. And so what we're gonna talk about today is some of this might be a little bit trite, and if it is, I apologize, but some of these examples we have to talk about in order to get to where we want to get to. And so let's start off. The word innovation, in my mind, I hate that word. It's the most overused word in business. People love to say I'm in innovation. You know, what does that word really mean? Well, innovation is nothing but a new idea, a new technology, or a new method. That's it. That's all innovation is. Notice in that, it doesn't talk about what problem it solves, doesn't talk about what business model it solves. And there's no defined product when you talk about innovation at all. It's just a new idea, a new method, or a new technology. When it comes to building a product and being successful there, it's the function of it's the function of 3 different things that actually give you an opportunity, and we're gonna talk about it. So when you start talking about building new innovations and new ideas, it's rarely a straight line to get from an idea to a product. It's usually very crooked and very backwards, and it goes crazy ways, and that's just how it is. And the people who are best at it leverage that and follow those paths. Keep in mind that anytime you have a new idea and a new technology, it's really, really hard to turn it into a new product. Really hard. Primarily because that new idea is not well understood or readily available to people. So the average person can't look at your idea and say, oh yeah, that's a great product, because they've never seen it before. It's not obvious to them. And the hard truth for everybody here, you are probably wrong about something. I don't know what you're wrong about. I'm wrong all the time, but this is kind of like baseball. If you hit 300, you're a Hall of Famer. You're going to be wrong about all sorts of things way more than you'll be right, and you got to be okay with that. So now keep in mind, a lot of this is my opinion, so don't think this is academic in any way, shape, or form. But I look at innovation and innovative product development in 2 forms. One, what I call closed loop development, and one, open. So closed loop development is simply this. I have an idea, I have a technology, here's the product I want to build. I'm going to go out and build it. Okay? And it works sometimes. It does. The innovation that you come up with, its success is tied to whether that product that you are defining is successful. So it's a very straight line. I'm building this to do this, and if this is successful, I'm successful. If your innovation in the technology doesn't work, that product doesn't work, the one you defined. And so you have to go back to the drawing board and figure out a better way to build your product in order for that product to come to life. If you get too focused in that, it becomes hard to imagine possibilities outside that scope. And one of the things we're going to talk about today a lot is some of the best opportunities are those opportunities that you never thought of as you're on that path. Open loop development is a little bit different. You start with a technology or a concept. Some technology you want to leverage, you want to build something. But your innovation is more exploratory. You're looking at that technology and you're asking yourself, what can I do with it? I can do this, I can do this, I can do this, I can do that. And the idea is you try multiple things, you build your skill sets, you build your knowledge of the technology, and at some point, the proper implementation or an implementation that turns into a project pops up for a lot of reasons. Maybe it pops up in your head. Maybe a partner says, I heard about this company having this problem. Or maybe you read an article and come up with an idea and figure out how your innovation can solve a problem. The advantage of this, the disadvantage is it's not very focused. The advantage is, especially if you have a team, it encourages skill growth. It encourages growth of an organization. It encourages creative problem solving. And if you think about it, when you're developing to multiple targets. So I think you have a better chance of succeeding. That's not to say closed loop can't work. It works a lot all the time, if everything is just right. So here's how I would encourage people to look at something. So when you look at innovating a new product, think of three variables: the technology you're building, the environment of today, and the business opportunity. Your success is a function of all three. And all three are always moving. They're always fluctuating. The environment is always changing, right? Think about today. I mean, for crying out loud, the geopolitical environment is going nuts, right? Right? So, but that in some ways it's gonna kill opportunities. In some ways it's gonna create opportunities, right? The business opportunities change. People try to do new things. Look at what AI is doing to the world, right? The businesses today are trying to figure out what is the opportunity that I can solve with AI. And the technology moves quickly. And so you could be 100% perfect on your technology and have something solid. You could have a great business opportunity and the environment can change, which will cause you to pivot. Same thing can happen with business. Same thing can happen with technology. So think about all these three things moving together, and the most successful new products and new ideas follow whatever path those variables take it. And they will change, and they'll change quite often. So here's the trite part, okay? We all know the story about Post-it, right? Post-it notes. So Post-it notes were invented in 1968. A chemist at 3M was trying to invent a super sticky adhesive, and he kept using it, and it wasn't super sticky, and every time he pulled it pulled off very easily, and it was a failure. It was a total failure for him because he was trying to build a very focused product, a super sticky adhesive. What ended up happening years later, another 3M scientist was trying to put notes on a church hymn book, and he found this adhesive, and he found out that he could stick it on the adhesive and it wouldn't tear the papers, and he could swap them in and out, and he thought, well, that's a great product. Came out to be 3M Post-it notes, right? It was one person's failure. Another person actually looked at that idea, figured out that there was a new business opportunity there, and it became really successful. Here's a more modern one. You ever heard of Shopify? Do you know how Shopify got started? It was started by a bunch of guys that were trying to sell snowboards on the internet. There's a company called Snow Devil. They wanted to sell snowboards. They were really, really frustrated because e-commerce was the e-commerce tools they had available were absolutely horrible. They couldn't find a great way to sell snowboards. So they invented their own e-commerce platform. And they found out really quickly, everybody wanted their e-commerce platform and nobody wanted to buy snowboards for them. So they pivoted and they became Shopify, right? New business opportunity and a new environment, an environment where the world was trying to figure out, how do we do e-commerce? Here's something that solves a problem. Both of those things changed. They pivoted and didn't sell snowboards again, but have a very, very successful platform that's deployed worldwide. All right, now I'm gonna show you an example that's gonna date myself. So I'm really not this old, but this is something that happened in the early 2000s. And what I'm gonna show you is a gentleman by the name of Brian Roberts. Does anyone know who Brian Roberts is? Brian Roberts is the CEO of Comcast and NBC Universal. He runs the whole company. His father started the company. And he's gonna be demoing, this is in, I think, 2007, an application that me and my team built. And this is, I want you to, you're gonna look at this application, you're all gonna think it's really silly. But in 2007, this was a really big deal. And let me explain why. In 2007, television systems, so the way you watch TV at home, was a very, very well-designed, very well-secured, highly proprietary system that delivered video signals from wherever they were coming from, a TV broadcaster or a sporting event or whatever, encrypted all the way through your cable to your home and decoded, decrypted, decoded, and played on your TV at home. That was a very, very closed system that was impossible for anyone else to develop on. Everything was 100% proprietary by only two vendors in the world. There was a company called General Instrument, and there was a company, or Motorola at the time, that's who they became, and a company called Scientific Atlanta. And they were the only ones in the world that built these systems to deliver television. That's it. What you're gonna see here is a mobile device that is actually gonna control the TV. You all probably do this today. You do it with your Roku today, okay? You can pull out your phone, go to Roku, stream a movie, and you can control it from your mobile device. What's interesting about this is we built the first prototype of this using a computer, running a web interface, controlling an old school cable set-top box. And when it worked, everybody said, wow, that's cool, but nobody in the world wants to do that. Nobody in the world wants to use their computer to control the TV. And by the way, that was 100% true. However, something happened. The environment shifted. So think around 2006. Anybody know what Apple did around that time? Maybe 2011, actually, I may have the dates wrong. Apple released a product the world had never seen. The iPhone? An iPad, a tablet. Nobody had any idea what a tablet was, what you could do with it, what its uses were. But they released a tablet. 2010. 2010, there you go. 2006. So this demo is 2011. So, and this demo is actually done on the very first tablet that Comcast got access to from Apple. It was a dev tablet. that we got, we told them we had this idea. We had built this demo. Nobody cared about it on a laptop. So we just said, holy smokes, the environment has totally shifted. There's this thing called a tablet. What happens if we run it on a tablet? And guess what happened? It exploded. And it exploded for two reasons. Number one, pardon my language, tablets were really sexy. People wanted to just play with a tablet. It was cool. It was touchscreen. It was big. The graphics were beautiful. And then the fact that this tablet controlled your TV, it was groundbreaking. People didn't resonate with it on your laptop, but with a tablet, it was cool. So we're going to show the demo. How do I play this? It's not playing. Let's see. Do I have to do that? Yeah. Of course, it's not playing.
The problem is you're on a laptop.
That's right. Why are we not? Why is this video not playing?
That security warning at the top relevant to you.
No.
References to external media others.
Oh, was it?
Yeah, it says on the PowerPoint. Like, great.
Doing the Wi-Fi?
Hand bar there.
Oh, right here, security warning. Oh,
Video down there like.
yeah. Thank you.
Okay. Well, that should work now.
Still doesn't work.
Yes.
Okay, I'm here on the floor of the NCTA convention with my friend Kevin from G4, who is the tech guru. Thanks for joining me.
Brian, thank you. I've seen 1,000 apps for the iPad, but not one that allows me to interface with my cable box.
Well, that's what we think we have, something pretty cool. Here's an iPad, state-of-the-art technology, running on the internet using Wi-Fi. We pair the iPad to your cable box through the magic of our eBIF application. Once that has happened, it's the same as pairing Bluetooth with a smartphone in your car. You now have a beautiful looking graphic giving you all of your channel choices. If I go to Comcast On Demand, what you'll see is lots of choices, and you can scroll through that. Or if I also want to say, go to search, up comes a keyboard. That's been the missing link for a lot of us with the cable box. How do I search 70,000 on-demand shows and beyond? I can then close up the keyboard and I'm back here. I can look at just movies or sports. And once again, I can now use it for something that I think is the most important element, which is to actually use it to control TV. So if I want to watch the Food Network, I turn to watch on TV. And just like that, it changes channel to Chef versus City. Now, if I want to say, let's watch Gangs of New York, I could record or I could watch on TV. So again, we've changed to Gangs of New York, but now it also lets me invite a friend. So I'm going to say invite friend, up comes Kevin. Now, he doesn't even have to know if he's got AMC or what channel it is. All he has to do is respond to my invitation.
And there it is. Instantaneously, you've popped up and you've invited me to watch Gangs in New York. Of course. Watch on TV.
And over here at this TV, in your house, you've now switched to Gangs in New York. You don't even have to know whether you had the channel, what channel number it is. We're pretty excited. We think there's a lot more innovation to come, but this liberates us from the cable box and puts it in the power of the consumer.
So that looks a little weird. It looks old, but anybody want to have an idea? So I got it. Me and my team got a patent for this. Anyone want to know the value of the patent for that technology?
Sure, I wanna know, I can't guess.
Yes.
I have no idea.
Okay. Over $1 billion. That idea is an over $1 billion idea. And the only reason we got there was because iPads were cool and we pivoted.
Cooler than iPhones. iPhones have been out, what, 5 or 6?
iPhones have been out, but nobody at that time thought of a phone doing that work. They're too small. The typing was too hard.
Mm.
And you also we had a big issue with phones. iPhones, while popular, there were a lot of Blackberries. Those were closed development systems. Android at that time was not great. It wasn't very mature. So phones weren't a great option, but this crazy thing called the tablet popped out. Perfect. So that was $1 billion idea, over $1 billion, actually. And now you have everybody doing something like this. Roku, Google, YouTube, everybody controls their phone or their TV through this, through different mechanisms.
So y'all licensed the patent, Comcast? Or did they?
No, so we chose not to do that. The way we looked at, first of all, what we did was we gave this technology to every single cable company for free. Because what was good for the industry was good for us. Yeah. We held the patent, still hold the patent, until a bunch of patent trolls bought other people's patents and started suing every TV provider. And this patent actually held off every lawsuit on that because we actually beat them by 6 months.
But is that your marketing partner who's actually on the screen?
The other guy,
Yeah, the guy doing the demo there.
so the guy talking was the CEO of Comcast,
Gotcha.
Brian Robbins.
Gotcha.
Yeah, the guy whose family owns most
So
of
he's the
Comcast.
son.
He's the son of Ralph Roberts, the founder, yeah, who's now the CEO of the company. So think of that, silly idea, just a pivot because the environment changed, and all of a sudden it went from worthless to totally changed an industry. So now I'm gonna show you a different story, and this is a really long windy path to, besides that, probably our most successful innovation and product we ever built. So when computer vision, this is before the AI craze, when computer vision first started becoming a thing, in Comcast Labs, me and my team, we made the decision that there was probably an application for computer vision somewhere in our business. We had no idea what it was, but there was probably an application. So we started this process of implementing computer vision in as many different ways as we possibly can to see what we could learn and see what would come out of it. So the first thing we decided, there was a big problem in the whole industry. Companies like Comcast and Charter Spectrum and Cox and all these companies, we had massive data centers filled with equipment. And we went to tour one of these data centers and we saw a bunch of men walking through the data centers with clipboards. And we asked the question, what are those guys doing? Well, those guys were being paid to take inventory of every server, every device stored in racks. And I'm talking about thousands of racks in a large data center. So they would have an inventory of where everything was racked and installed. And it's a little bit like, you know, the story of the Golden Gate Bridge. You start painting the Golden Gate Bridge on one side, and by the time they're done painting to the other side, they have to restart painting the other side again. It takes that long. By the time these guys would all finish with their inventory, the inventory would be completely invalid because equipment had been swapped out for months. And so they would pay all this money to get this inventory in the data center, and the moment they would publish it, everybody would say, that's a worthless piece of junk. We don't use it. So we decided we were gonna use computer vision to solve that problem. And because we were arrogant, we decided to use a robot first, because who doesn't want to use a robot first? So we built it with a robot. And then we realized, and I'll go show you these examples, that humans were better than robots at certain things.
Thank you.
Yeah, yeah, certain things, not everything. Humans in this case were faster than the robot could be. And we realized, we're gonna transition that into an app on a phone. And that got deployed. And that got deployed pretty well. And then COVID happened. And right when COVID happened, nobody really knew how to work, well, not nobody, but our industry did not know how to work from home. Had no idea how to work from home. And we had a group of people who had very specialized jobs that had to come into the office. And they had to come in the office during this very scary time when you had a global pandemic. And so we had our computer vision done, we had these robots that we had built, and we decided to reuse our robots, and we reused our robots to, in these areas where people had to come work, we built UVC light disinfectant robots that would drive through the facilities during their breaks, disinfect everything, and make people feel a little bit more uncomfortable. Now, was it really that effective? I don't know, but people felt more comfortable and nobody got sick, so, maybe it was. Then as COVID got worse and worse and worse, the CTO of our company came to me and said, I need your team to solve a really difficult problem. And that problem is, it's a global pandemic. People have to come into homes. Technicians have to come into homes to try to fix their cable, try to fix their TV, their cable modem, their broadband service. And we don't want to get them sick, and we don't want the customers to get our technicians sick. So is there anything we could do to build tools that would allow a cable tech to troubleshoot problems from outside the home and not have to come in the home? So we started looking into this problem, and we'll talk about it, but we built an app that to this day is not only still deployed, but has grown into a massive app that allows technicians to troubleshoot problems outside the house that are occurring inside the house. And we'll talk about it. But keep in mind, this is one path with the same technology that we went through, and we followed the winds and ended up with probably the most successful in-house developed tool that Comcast has ever deployed across its footprint.
So I have a question,
Yeah,
and it's about pivoting, right? So
Yeah.
there's like this theory around like when you invest in something, it's really hard to let it go.
yeah.
So what do you do, as a team, innovation team, to let go? Because you have to let go of being
Yeah.
married to, I
You do,
developed this
you do.
for this purpose, or I developed this app for this purpose,
So it's the hardest part of all this.
right?
And I will say this, we actually hire people that are not married to technologies or ideas. So we actually look for personality traits. We look for people that want to learn lots of things. Because those people tend to say, oh, okay, that didn't work. Let's try something else. I want to do something else. So in some cases, it's actually beneficial to have people who like to do more things than just one thing. Like in a job in this space, I stay away from the person who says, I do Python. I do JavaScript. That's what I do. I am only a drone person. That's what I want to do. I want to build applications that involve drones. That's it. That's all I want to do. Those people have that bias where they want to make it work with their technology, or they want to make the business work only within drones. Now, if you're hiring for a drone company, great, that's what you want. But it's hard, and you need the right people, and you have to have people that are okay with giving up.
So has there been a moment in time where you were like, no, I'm not gonna give this up?
Me personally?
Yeah. Like, I developed this for this purpose and.
Be honest.
Yeah, I would say there have been times where I've been 100% convinced that the way we are doing something is right. And either it's the wrong time or the wrong environment to do it. And I've had to go kicking and screaming. But
So did
You
you
have to.
just surround yourself with people that helped you as you kicked and screamed to get out of there? Or what did you do to like, but I asked this because I think we all like, at some level, we can be this passionate about
yeah,
this area of life, but man, if it's another area of life, like forget it. Like,
yeah, I mean, you go kicking and screaming and you look for the next shining object.
Well, I think it's right,
Yeah.
so great for the Shopify guys who made a lot of money. But we're still missing that better snowboard that they had.
Right, yeah, good, maybe it was the greatest snowboard of all.
And oh well, cause
Yeah.
they pivoted because they saw opportunity.
That's right.
Recognize the change in environment.
Yeah,
Not wrong, but
yeah,
I'm still want that snowboard.
yeah, yeah. So, this is the essence of the problem. And I have seen more startups fail
because they don't.
because they're unwilling
Hmm.
to give up on an idea. I've seen tons.
And Jack, it's tricky too, right?
Yeah,
Because you'll also see teams that.
Yeah.
You know what I mean?
It's a
And
fine
they don't
line.
stand something long enough to like, do you have something?
it's a fine line, and especially like some technology like robotics, the life cycle to build something there is long.
Hmm.
It takes time, and you have to stick with it till some point, right? It takes, people don't build robotic robotic factory lines overnight. It takes a long time.
In farming, it's 15 years before you know if you fail.
That's right. So like the life cycle is different for, in medical tech. Can take forever because you're waiting for FDA approval, right? If you're building an e-commerce platform, yeah, that's probably something you can pivot really quick on, but like the one thing I would just recommend is you have to hire the right people who are okay changing paths. If you hire obstinate people, this will be a problem. Yeah,
So I mean, obstinate is one thing, but like to Mark's point, they may just want to do the other thing, right? Like you can want to do something with your life that isn't obstinate.
So I'll give you a great example of that. So we had a woman who worked for us who was probably one of the smartest data scientist engineers I've ever had on a team. She was phenomenal, absolutely phenomenal. And we were trying to build a tool that would predict when a network would go down and automatically repair it before anybody would notice. Very complicated problem, and a problem actually that is more of a data science problem than an actual technical problem. It's really about real-time data and understanding what's happening in the data and understanding why and moving very quickly on it. We actually got pretty far and showed some promise in being able to build this, only to find that in the end, the problem was far more complex than we even understood. And it wasn't going to work. And this woman, absolutely brilliant, she wanted to solve this problem. And it got to the point when we had to move on and say, we can't solve this problem today with the current tools. She left. She left to go work for a company where she had become passionate in solving this problem, and we couldn't do it. And so she went to another company where she could try to do it. And sometimes that's what has to happen.
Did she solve the problem?
No. She ended up doing something else. Brilliant woman, and I still talk to her, but that she didn't want to let go. And when we said we're not going to work on this anymore, it crushed her. And it happens.
Not yet, she hasn't solved it yet.
Not yet. She might. I wouldn't put it past her, but yeah, it happens.
We should let you go on, but this is
Yeah.
definitely a fascinating piece of the puzzle.
It is, yeah. So here's an example. So this was the robot that we first built. And what this robot is doing is it is driving down a data center and it's taking a picture of every rack. And in it, we actually built the computer vision models for every piece of equipment installed. And I don't recommend anybody doing it. It's a horrible job. It's awful, absolutely awful. And the robot is actually building the inventory of what's deployed in this data center. And it's recognizing where there's gaps in the data center, which is actually, we found out, that was really hard. That was really hard, especially when it saw equipment behind it.
Yeah.
So our vision of this was that robot would sit there and sleep, and every time a technician would come in and swap something out and put something else in, it would deploy, take a picture and update the inventory. No surprise, there was a ton of resistance to this. Did anybody know why?
Jobs taken away.
Nobody wanted a robot.
Yeah.
Nobody wanted a robot because it would cost jobs.
I was just saying, there's a bunch of guys down at the bar with clipboards.
Yeah, that's right. Nobody wanted a robot because it would cost jobs and cause problems in the workplace.
Yeah.
If a robot started, big culture issue. The environment did not support this at all. Because the environment didn't support it, there was no business case for it. Okay? So we went on. So then we decided to do a test. So we built the same application on an iPhone and we gave it to a technician and we said, walk down and take pictures and upload each picture and then we'll use our computer vision model and build the inventory. And came up with this. And this is what it looked like. And the technicians would walk through, and actually, we found out the humans were 60% faster than the robots.
Was that just a speed issue of the robot and the technology of the robot itself, or was it a matter of, like you mentioned,
Probably.
like you mentioned, for example, the racks that were empty, the computer reading was getting confused and stopping, whereas a human could just go, oh, there's nothing there, I can skip this one.
It was probably the robot. And we had the solution for it, which never was gonna fly. And it was drones. So we actually built it internally with drones. With indoor drones that would fly and go up, down, and you can imagine they went a lot faster than the robot. Sure as hell not putting a drone with spinning blades in a data center of very expensive equipment. And
How fun though.
it was fun, but the moment we showed it to, we showed it to, at the time, the SVP of operations was, a great woman. Her name was Sharita Caesar. She had been, in the industry for 40 years and brilliant woman. And we showed her the robot and she was like, well, that's great. It's too slow. And we said, yeah, but watch this. And we flew the drone and she looked at me and said, oh, hell no. And that was the end of the drone. So, but the humans were fast. So that application is still deployed today. And then just for fun, we repurposed the robot. This was because we couldn't come in the office at the time, someone's basement. The robot had a UVC light mounted on it. And we would program, once we brought it back into the office, program paths for it. And during breaks, people actually would have to leave because these lights would give you sunburn, pretty bad. But once people would leave, the robot would go through, disinfect, and make people feel more comfortable. So now we'll get to. All right, stop. Okay, now we're gonna get to where this really came. So after we were showing everybody and using the computer vision in the data center, this is when the CTO of the company said, I need help trying to figure out, can you use that somehow to solve problems for the technicians so they don't have to go in people's homes? We can't keep sending people's homes during a global pandemic. That's just not good business and not good for the employees and not good for the customers. So we started doing research about what causes problems in customers' homes. So I'm gonna bore you guys with details, but if you have any type of cable service at home, on the side of your house or on the side of your apartment, there's a box where the cable comes from outside into the house. And when it comes into there, all sorts of things have to happen before it goes into your house. So cable network is just like any network. There's lots of noise. So, and the noise can be introduced by bad connectors in your neighbor's home. The noise can be introduced by, I'm not joking, a squirrel up on the cable chewing into the sheath around the cable. And that lets in RF coming in from anywhere into the cable plant. And so you have to have filters at the side of the house that prevents that noise from getting in the home. You also have to have the home, that cable has to be grounded properly. If there's a lightning strike, you can set people's televisions on fire if it's not grounded properly. You can destroy the electrical system in their home if it's not grounded properly. There's all sorts of things that have to be done within that house box for everything to work properly in the home. And we found out that about 60% of most of the problems that were being experienced in customers' homes were a result of the technician doing something incorrectly outside the house. Right there, we thought, well, we got a gentleman who is a fellow in the company who was the top cable technician in the whole industry. Guy who's been doing it for 45 years, brilliant guy. And we asked him a question and we said, if you look at a house box, can you tell me what's wrong with it? And he said, of course. I can tell you everything wrong with it in one look. Well, if a human can, an AI model can. So it was the perfect use case. So what we decided to do was we were gonna take care of 60% of those problems by when the technician leaves the home, they take a picture of their work on the house box and we tell them, here's what you did wrong and here's how to fix it. And if they can fix it there, things will improve. And so it started out, I'm not gonna show this whole thing, it's kind of a boring demo, but, oh, you can't really see it, it's too small. But this is the beginning of our research in building that model. And the way we had to do it, once again, I never recommend to anybody, don't go build your own computer vision models, look for open source. Trust me, there's a lot out there. But what we actually had to do is go across the whole country and have senior technicians take pictures of bad and good and tell us what's bad, what's good. And we did this for about 6 months, just acquiring images and building a model. And unfortunately, I can't show you the actual application because it's proprietary. But here's an example of a test app going to my house. This was years ago, taking a picture and it's showing, here's what's right, here's what's wrong. In fact, I found out my house was all messed up when I did this. So sent somebody over real quick to fix it. But these are all of the things we see that what was missing in here was a filter. I didn't have an upstream filter. So my next door neighbor, all of his noise I was getting in my house. And then if we run over here, it's looking at the grounding going into the house. I'm taking a picture of it. And this isn't the actual app. This was our test app that we used to actually build the model. And it's what's green is what's good. What's red is what it's not recognizing. Here are the problems. So this app, we ended up deploying in late 2020, early 2021. The app's still deployed today. And technician adherence to specifications and doing it right since we deployed it has gone up 85%. So you think about what that does to the customer experience inside, it's a big deal. It's a real big deal. This was such a big deal, the organization that we handed this technology off to built a whole new organization just around this technology to grow it. And they've been growing it for the past 4 or 5 years.
So, you said 6 months of training data collected.
Yeah.
How many boxes does that mean?
Thousands upon thousands, and we had to do it in different regions, because for whatever reason, technicians in Minneapolis did things a little bit different than technicians in Atlanta, because they would buy different filters, which would confuse a computer vision model because they would look different.
And so how often do you update it now? Because you have newer boxes, right?
So they, No, so I think they've gotten to the point now where they've grown it, where the variety isn't as much of a problem. They've pretty much caught all of the variety out there. To the point now where when there's a new piece of equipment that they buy, they update the model and they're fine. It's that first time going through and then realizing that nobody adheres to specifications that makes it really, really difficult, really difficult.
But I have a question.
Yeah.
I have to ask my question and then go.
Yeah,
Surely there are other industries that have similar problems that are not in the telecom business.
yep, yep.
And so is the tech ops organization that took over this app looking at other application domains and selling it to other industries?
We tried to get them to do that. We tried hard. And the tech ops group was focused on solving problems for the company, not commercializing other problems. But you're 100% right, like, aircraft maintenance uses this technology everywhere. Auto manufacturers use this technology. I know
Technology as in use, the same thing that.
they've built similar things without us. They did their own thing. Yeah, yeah. And now it's actually a lot easier to do it because people have actually built CV models for everything.
All right, I apologize.
Yeah. You know, I know of a company that inspects tanks in Navy ships. And they use it to detect cracks in the tanks or areas where the coating is peeling or things like that. So this is deployed everywhere. We were just on that early forefront. I think, to Mark's point, had we built an organization around commercializing this, we probably could have done a lot and I think could have commercialized it outside the industry, but our company was focused on only solving problems for the company. This was a big enough problem.
Yes.
They didn't want to get unfocused. So a reminder, technology, environment, business opportunity, three variables that always move. You always have to be observing what's happening around you. And if you have an opportunity to follow it, follow it. I've seen great companies that have been built that wanted to build this product, started here, followed an opportunity here, followed another opportunity here, followed another opportunity, and all of a sudden they had the money to build what they wanted to build all along. You've got to follow that opportunity and not be so stubborn. You're not gonna look at these crooked paths to get where you want. That's why,
Get his snowboard then.
yeah. Maybe they'll go build that amazing snowboard.
So I have a question
Yeah.
about like reintroducing an idea, right? So the drone is a relatively new idea in a room, a warehouse of computers, right? So is there something about like reintroducing it?
Yes.
We have like early adopter, late adopter, so that person may have not been ready yet.
Yeah, or it's very true that sometimes everything is right, it's just not the right time. So I'll give you a great example. So 4 years ago, my team did a proof of concept of trying to manage network outages with a quantum computer. So we used, you guys know what D-Wave is? So D-Wave is a commercially available quantum computer that you can buy time on to run algorithms. And we wanted to test out, could we analyze a network issue faster with a quantum computer versus a traditional computer? And we went and we did it and it worked. The quantum computer was faster. But it was so costly, it wasn't, there was no payoff for it. It was costing you money to be faster. So much so that it was no benefit. So we shelved it. 4 years later, now our network organization is actually using it because the costs have gone way down. The tools are much better, the time is right. So a lot of times, everything is right, it's just not the right time. And what we typically do is we don't ever throw anything away. Because there's always an opportunity when the environment changes and now maybe the time is right, or the business changes and now the time is right, you reintroduce the idea again. And that's a real thing, yeah, 100%.
So in that case, it's really important to maintain your team and the
Yes.
team's history and people.
Yes, yeah, it's critical, because you build, in a lot of these cases, expertise in very specific people, and if you have a lot of turnover, that makes it very, very hard. Very hard. Yeah. So we can either walk through some examples if you all want, or just you can go off and do it on your own, but as you start thinking of things you want to build, think of all three elements: the technology you're going to build, the environment of today, and the business opportunity that you think is the business opportunity. And what I like to do is then in each one of those, think of how they could change. So let's think of the environment, for example. Let's say you want to build something, a physical product, right? The environment's changing. I'm just making stuff up. What do future tariffs do to that environment? Does it make what you're building too hard to build? Or is it an opportunity? If you build it here, you can overtake somebody who is maybe outside the country. How has AI changed the environment? Does that provide opportunities for you or not? So think of the different things that can change there. Think of the different business opportunities that you can have. And be okay if you take your technology and build something in a totally different business opportunity with a totally different opportunity than you thought you were. You might get to where you want to get to eventually, but follow that path. It'll build your skill sets, it'll build your technology, and it'll give you an opportunity to get good, important experience under the belt. So think of how all of those things can change and be willing to follow whatever path it takes you. I think that's really important. Any questions? I hope it didn't sound too trite and overly optimistic, but it's based on a lot of real world experience. If you're one of the people that builds a company that is going after one specific product and you get there and you're successful, more power to you. That's amazing. I'm not going to say you were lucky. I'm just saying everything went right. And most of the time, not everything goes right. And sometimes you are right. The environment or the business isn't ready for you. Cool. That's all I had.
Thank you.
You're welcome.
Any particular business opportunity on the horizon that you're chasing right now?
So right now I'm actually, consulting with, a handful of startups right now. one in, the advertising space, which is kind of interesting, one in the quantum computing space, which is really, really fascinating and really hard to figure out what a product would be. And a couple others. I'm gonna roll my eyes saying this a little bit, but you know, AI is on everybody's, you know, main, you know, tip of their tongue. AI is incredibly impactful. I think AI right now today is really good at solving 80% of what might need to be solved, but the rest of the 20% is really, really hard. So I think there's opportunities in like really figuring out how you truly operationalize AI, so it doesn't make mistakes.
Oh, good luck.
Yeah, I mean,
It's like a human not making a mistake, right?
yeah, well, AI's a little bit worse.
OpenAI just
Yeah.
came out and basically said it's impossible for them not to have hallucinations, just because the way the model is set up,
Right.
it
Yeah.
has to happen.
Yeah, and I think people get confused a lot with AI. I think there are a lot of problems that people are trying to solve with AI that are more easily solved with things like machine learning or other stuff that is just perfect to solve some of these problems. And so a lot of it is controlling the hysteria around everybody just wanting to have a .ai after their company name. I think that's pretty interesting. I think robotics is gonna become something that is bigger than people are giving it credit for right now. I think robotics in all facets of life. Yeah, I think yeah.
I went to a sushi restaurant last night and the robot comes in and just like.
Yeah, why not? Why
That
not?
feels pretty Japanese, actually.
But if you think about it, it's not that complicated of a problem to solve, right?
Mhm.
You know?
No, that's hard to know on the tip.
Yeah, well, yeah, that's a good question. I have no idea what to do there. Do you tip a robot? Yeah, yeah. Yeah, so,
They're developing robots to babysit too, right?
yeah, yeah. I think, it's gonna become part of our everyday lives, whether we like it or not. It just will.
And I saw my first Waymo car yesterday.
Yeah, my youngest daughter goes to Arizona State. And if you've ever been to that campus, there's Waymos everywhere. And if you call an Uber,
Okay.
it'll give you an opportunity to get in a Waymo. And no, thank you.
I lived down in Denver, so I was driving up here for class, and it was not one of the self-driving ones. It was one of the ones that have all the sensors on, so they're picking up all the data as they get ready for launch.
Yeah, it's probably one of the first ones, and I think they have to have a driver
Yeah,
sitting in there.
yeah, this one, I don't think this was, there was no passenger, it's very
Yeah.
clear, like, this was all for the LiDAR, all that kind of
Was
stuff.
it the Jag?
Yes,
Yeah,
but it was, all the sensors, everything, I saw,
Yeah.
like, hey, I'm.
yeah,
They're
yeah,
fully operational in San Francisco.
yeah, San Francisco and Phoenix, I mean,
And LA.
yeah, they are all, like Tempe, Arizona, you can't go anywhere without seeing 5 or 6 of them. They're everywhere.
They're limited in distance though, because I wanted to take one from Palo Alto to the airport. And
They don't go
I
that
think
far,
it's-
okay.
There's some of that is because the municipalities won't let them.
Ah,
So they have to stay within a city that approved autonomous vehicles.
Okay.
So like the Tesla ones in Austin right now, are within like a 2 square mile area.
Yeah. Yeah. So,
okay.
yeah, thanks.
Thank you.